What's up, everyone?
This is my ramp example. I have a 5-pound weight right here, and if I lift it, I'm taking on 5 pounds of weight alone. So directly 5 pounds of weight. That's how much force I have to exert. So in order to get from this place to this place, there's roughly a 3-inch difference, as you can see, from the ground to the books. So that means that in order to get it onto it, I would have to lift it and put it on top. So if I didn't want to exert that much force, or if I couldn't exert that much force, I would have to use a ramp or some other sort of simple machine. So in this case, we're using an inclined plane, and inclined planes are very good for this type of object, such as rolling, or I could use another object such as a heavy book and show you. But in this case, we're just going to use the weights because it's more uniform. Instead of exerting 5 pounds in this case, I exert less force because I can roll it up. And it's much more easier than lifting 5 pounds because ramps give you mechanical advantage. So these are the dimensions of the ramp. It's got a 3-inch height and an 11-inch hypotenuse, which is this part and this part, respectively. The height 3 inches and the hypotenuse 11 inches. So, in order to calculate mechanical advantage, I would have to divide this hypotenuse length by the height. So, we have a mechanical advantage of 11 divided by 3. So, what is 11 divided by 3? It is 3 2/3. So, in order to get the amount of force I exert on this object, I need to multiply by the force that I have to use in order to push it up. So I would essentially have 3 2/3 times as much force that I used if I were to use this ramp, compared to me just lifting the weight, which would mean that I would have to take on exactly 5 pounds of weight directly. But this one, I only have to exert less force in order to roll it up.